Hello and welcome back to Jason Live. My name is Patrick Shea, and we are here with our STEM Career Series once again, where we learn about careers in science, technology, engineering, and math from role models currently working in those fields. Today's role model is Dr. Roberto Venegas. He's an oceanographer with NOAA's Coral Reef Ecosystem Division. He's joining us today from Hawaii. We're going to learn all about Roberto and his career as an oceanographer in just a moment. But before we do, I want to remind all of you out there that today's event is live and interactive. We'll be taking your questions. You can send us questions using the box just below this video window, and we'll try to get to as many of those as we can today. Right now, I'd like to welcome Roberto to the program. Great to have you, Roberto. Thanks for joining.
Aloha from Hawaii, Patrick.
Aloha.
How are you doing?
I'm doing great. So we're really excited to learn all about your career as an oceanographer. Why don't you get us started? Actually, to get us started, I want to bring in a question from Mrs. Dabb's class. We have it right here. What exactly do you do as an oceanographer?
Well, let me start thanking you for inviting me to talk about science today. And well, I can tell you that I am an oceanographer working for NOAA Fisheries, specifically with the Coral Reef Ecosystem Division in Oahu, Hawaii. As you can see in there, we have a map of the Coral Reef Ecosystem Division areas where we go on monitoring and sampling. Let me start with mention that oceanography is a science that studies the ocean and has four disciplines. We have biological oceanography, physical oceanography, as you can see in there, chemical oceanography, and geological oceanography. Biological oceanography is more related to plants and animals in the marine environment. Physical oceanography, it's related to the condition and process in the ocean. Chemical oceanography study more water composition and cycles. And geological oceanography study the ocean floor formation and change. So our mission as CRED, the Coral Reef Ecosystem Division, is to assess, monitoring, and provide scientific information about the status of coral reef ecosystem at different islands, group of islands. The main Hawaiian Islands, the Northwest Hawaiian Islands, the Marianas Islands, Samoa, and some other remote U.S. territories. We are also providing technical and scientific assistance to countries in the Asia-Pacific region. As you can see there in that image, one of our team member, and I'm going to mention that in a little, it's retrieving one of the temperature sensors that we have to measure temperature and long-term time series. Let me say also that we have different groups in CRED. We have 5 different specific groups. We have the marine debris group, we have the fish assessment group, which Kevin was part of that, ventic assessment, the ventic habitat mapping, and then the oceanography team. In the oceanography team, which is called the O team, we have 7 people in there. We are all science, and we do different aspects of oceanography. The O team is responsible for the maintenance, deployment, and retrieval of oceanography instrument, data analysis, interpretation, and dissemination. To complete these tasks, we use different platforms. Those goes from large vessels. We have our own vessel, the Hilialakai, which is standing all the time in Pearl Harbor in Hawaii. And we also have small boats where we do specific boat operations. Because this vessel that you are seeing is a large vessel, so we cannot reach very shallow areas. So we need to use these small boats where you can feed between 6 and 8 people. And you can see in the boat that we have the diving and some oceanographic instruments in there when we go to the water. So let me tell you that you showed before some kind of equipment that we have. And we use lift bags and heavy weights. We deploy those heavy weights in a specific location, and then we use we tie instrument. Yeah, that is the pictures. So you can see how we move heavy equipment just to protect the coral and also to protect ourselves. And it's easy also to move this heavy equipment. We have different kind of instruments. Yeah.
So, Roberto, you mentioned before there were 4 different areas of oceanography: biological, chemical, geological, and physical. Which area are you most focused on?
I call myself the biophysical oceanographer. Uh, yeah. I also work with climate data, and we are having this collaboration now with the scientists at the University of Hawaii, and the National Center for Atmospheric Research in Colorado. And we are trying to understand from the biology and the physics point of view how these new predictions about climate change are going to affect specific areas, specific coral reef ecosystems around the world.
So I understand that one of the tools that you use quite frequently is remote sensing, or gathering data from satellites that orbit around the Earth. And we have some video here from NASA that would like to show that kind of puts some of that, how you use that into context for the students out there. Can you lead us into this video? Let us know what we're going to be looking at.
Sure, sure. What you are going to look now is a short video from NASA. The title is "The Ocean: A Driving Force for Weather and Climate." And basically, what you are going to see is a nice overview of ocean process observed from space. Basically, from sensors, different kind of sensors that we use to analyze the process that are occurring in the ocean.
Awesome. We're going to take a look at that right now. Stand by.
Thank you.
Earth is the water planet. Although 40% of Earth's population lives within or near coastal regions, the ocean impacts people everywhere. Most of Earth's water is stored in the ocean, a driving force for weather and climate. The Earth's surface is warmed unevenly by the sun. Heat, a form of energy, helps drive ocean and atmospheric circulation. The ocean absorbs and stores more heat than the atmosphere. Both the atmosphere and ocean move heat. The atmosphere does this quickly, the ocean slowly. At the ocean's surface, winds drive currents. Multiple forces keep the global ocean conveyor belt, or thermohaline circulation, in perpetual motion. Below the surface, deeper currents are driven by differences in density. Mixing and upwelling in the ocean, transporting nutrient-rich waters to the ocean's surface. Nutrients sustain biological productivity in the ocean. Extreme variations in sea surface height and sea surface temperature affect ocean and atmospheric circulation. El Nino and La Nina occur when changing wind patterns displace warm and cool water in the equatorial Pacific. Both have global impacts.
All right, we're back with Roberto Venegas. Roberto, those are amazing visuals that we get from animating the data that we get from satellites.
Right.
Why is collecting video or collecting data in this way so important to what you do?
Well, basically, what we do as oceanographers, and we started a long time ago doing this around the world, we have very patchy data sets. So we can go on a cruise to a specific region, and that is very expensive, and then you need to come back. So you lose that timing between that cruise and the next one. So having this information from satellite can provide you continuous data sets that you can analyze and be more clear about what you are trying to understand. If you are looking for temperature, you can have today basically full data set at 4 kilometer resolution for the entire globe every day, and some sensors every 3 hours. So yeah, it's amazing what we can produce. So to have these tools and to have this data to better understand oceanography processes, change, trends, and variability in general, it's very, very nice. And I am very happy that I work with this.
We've got another question from our audience here to continue to put all of this into context. They want to know, why do we have to know about the oceans? What's the point of collecting all of this great data?
Well, from a point of view, the coral reef group now, we need to understand the patterns that are related to the conditions in the coral. So it is important to understand what is the temperature that is associated to these islands, what are the currents that are collecting these nutrients and bringing this amount of nutrients to the area to continue with the feeding of the chain. I'm talking about phytoplankton, zooplankton, fish, and so on. So it is important, not just for the coral reef, but in general, to understand the dynamic where we live. Also, from a point of view of transportation, we need to understand where we should go, where the current is helping us to go from one side to another, so that we should not cross this area because it's dangerous. You have big waves, you have eddies that can pull you to some specific areas, or can be more expensive to cross if you have small boats. Those kind of questions are related to why we need to understand. Oceanography is very wide.
Our audience is also very interested in some of the other techniques you use to learn about the ocean. They want to know about getting a little bit closer. How deep in the ocean have you gone, and what did you see? And another question, have you ever been to the bottom of the sea in a submersible?
Well, I have been lucky to be at a feet diving. That was a long time ago in Chile, and we were practicing about deployment of instruments at that time. That was very interesting because what I saw just in the first few meters of the water was what was most impressive for me. Actually, it was a school of small fish coming to me, and then behind this, I saw a big body moving just in my direction, and that was a penguin. That was my first time that I was diving with a penguin, actually. It was kind of scary, but yeah, it was fun. Now I'm laughing about that. So, sorry, your second question was, if I went to the deepest part of the ocean. Actually, I haven't been in there, but I have a very good friend that he did that, and was very amazing what you can see, and the sensation, the feeling of being by yourself at that depth and be able to be there. Pressure is tremendous on top of you.
What's the deepest you have been?
90 feet.
Okay, there we go. We've got another question coming in here from Carrie. She wants to know, what do humans do to damage the coral reefs, and what can we do to better the condition of coral reefs?
Well, we do, as a human, a lot of bad things. As well, we do a lot of good things too, but we do a lot of pollution. We do a lot of fishing in the coral reef, and sometimes we overfish those areas. So to summarize, what are the easy steps to help corals? For example, we should be more conservative about the use of water. the less water that we use, the less water that is going to run off to the ocean and move pollutions and sediments over there. Talking about pollution, I think everybody should be using a bike and using the local bus instead of individuals driving in their own car. In that way, we will reduce the amount of CO2 that we are putting in the atmosphere, which is absorbed by the ocean, and then temperatures are things, and then we have the effect of the ocean acidification, which is the decrease in pH, which will affect and is affecting directly coral reef because they are built. The structure of the corals is calcium, basically. So reducing the pH is damaging the corals. Another one could be use of organic fertilizers instead of the chemicals that we are using. You should support reef-friendly business. So if you go diving, try to go with a group that is going to take care of the reef. You can also plant a tree, basically, because you are going to reduce the amount of CO2 going to the atmosphere and indirectly affect the coral. If you go diving and snorkeling, do that safe, and that is going to help, to reduce the damage in the coral ecosystem.
We have another question here from a viewer, and they are also concerned about the health of the coral, but this follows up on one of the images we saw earlier. They want to know, how does the temperature probe stay on the coral without killing it?
Well, we have this, basically the temperature sensors that we are using are probably no longer or larger than 12 inches. So, and the diameter is probably right now, the new instrument is about half an inch, 3/4 of an inch. So we tie those instruments to corals, and we try to do this very careful and try to find the best way to leave the sensor in a manner that doesn't damage the coral, and also is very easy to see. You can imagine that we are going to, we go normally to these remote islands. So to come back to that specific location and then dive and find that specific sensor, that depth and that specific coral, it's very difficult, it's complicated. So yeah, we need to deal with a few methodologies that we have to prevent damaging the coral. Yeah.
Great. We actually have a video question that came in earlier, and we're going to listen to that right now.
Sure.
Hi, I'm Maxie Wolf.
And I'm Larson Schaub.
And we're from St. Philomena School in Peoria, Illinois, and we'd like to ask you, how does your job affect your everyday life as an oceanographer?
How does your job affect your everyday life as an oceanographer, they want to know.
Okay, thank you. Well, affect my life a lot, basically, because I can tell you that I have only 1 year here working with CRED and working with the Coral Reef Group. So has been a very new experience for me. So be part of this oceanographic group, being in the water, though, that means they pay you to be in the water looking at the coral and doing something. It's amazing. So every day that I have the opportunity to go with my group and then go with my family, I really enjoy. So yeah, oceanography, it's a full time my role here, and I really enjoy it.
That's great, and that's actually a great segue into our next portion of the program. We're going to talk about how you came to be in the position that you are in now. What made you even think to go into oceanography as a career?
Sure. Let me start with that. Mention that I am from Chile, and I was born there a long time ago. So you don't want to know that. But basically, I was lucky to that my parents have a house on the beach. There every summer, every winter break, every long weekend. So I was in the water every single time. So as you can see here, I put together this map where on the left top part you have the map of South America, and you can see where Chile is located. Well, on the right side you have the same idea, and then you have Chile in there. I was born in Santiago, which is the lowest arrow in there, and then I moved to Iquique when I was 17. I moved to that city because I was doing my bachelor degree in marine biology. Um, when I was doing that, I was very, very happy that I was able to dive, participate in cruises. I was able to work with different marine animals, from plankton to fish to dolphin. Actually, that is a picture of my first cruise, and that was when I was 17. That was around 500 miles offshore of Chile, and we were doing oceanography as the old time. We don't do that anymore, and that was very risky, thinking back in time. But from there, once I finished my bachelor, I moved to the central part of Chile again, and I was part of a very large international group of marine ecologists. So from there, later in 2000, my family and I moved to Oregon, where I started my in oceanography. Basically, I did my master in Oregon State University in Corvallis, Oregon, and I was there for 12 years. After I finished my master, I was able to work with one of my friends now and advisor at that time, Dr. Ted Struve, and also Dr. Ricardo Letelier, who were helping me to build up this career. So in 2012, we move again, and then we are here now in Oahu. So enjoying the weather, enjoying being in the ocean every single day, and enjoying new friends.
We have another related question from a student in Miss Dabb's class. They want to know, how many years of college did you go through to get to the point in your career that you are now?
Sure, that's a good question. Actually, did my master degree in 2.5 years, and basically was a summary of all the oceanography disciplines, and then my specific thesis was related to understand oceanographic patterns in Washington and Oregon coast, and by using most of the data from satellite, actually.
I've got another question. This one comes all the way from Australia. They want to know, what subjects would you recommend to high school students if they are interested in your career path?
That's a very good question. You should take all the science classes for sure, and that can give you a good base to go to school, and then have more background about what they are going to teach you, because it's going to be a little more tough and a little more of understanding of the connectivity between the different science, specifically if you are going for oceanography.
Our next question is from Bailey. They want to know, if you could have any job in the world, would you choose the one you have, or would you pick something different?
Definitely, I will stay where I am now. Yeah, I really enjoy it, and I really like it where we are, and my family is happy with that. So that is a compliment too. And I invite you to look at oceanography.
It's a good place to be.
That's
Happy with what you're doing. We've got another question here. This one's a video question from Luke.
I'm Luke from St. Philomena's School, and we were wondering, as a kid, who did you look up to and respect?
As a kid, who did you look up to and respect?
As a kid, based on the oceanographic point of view and the marine area, of course, Jacques Cousteau was the person to follow. He showed me that feeling about the ocean. He showed different colors. He showed me the opportunity to dive in the water. So yeah, definitely, I am very happy that I had the opportunity to follow him. And unfortunately, I never met him, but just by going to the ocean is basically feeling what he taught me at that time.
Here's another follow-up from Angie to that last question. If you weren't an oceanographer, what would you be?
Uh, I will say archaeologist. I really like that. And basically because during my field work, especially in the north part of Chile, we did a lot of oceanography in the coastal area. We were able to go to these remote areas where nobody was living in there for, I don't know, natives people were only there before. So we found a lot of marine fossils, and that was impressive for me. Yeah, if you have the opportunity, try to go to one of these regions where you can find fossils. That's amazing.
We're going to talk about fossils just at the end of the program, too, actually. That's our event next week. We want to talk a little bit more about you, just the personal side of your life when you're not working. And we have a question from Ethan that's going to get us kicked into that area.
Sure.
He wants to know, what do you do when you're not working?
Well, I have a family, and I have so we try to go to the beach every day if we can. And when I have time, I have my own kayak, and I enjoy my kayak, and I like go fishing. I like to be in the water if I can most of the time. So yeah, you can see in there that I was building that kayak in a fishing machine. So I will see in the next few weeks how that works. I am still in that process.
Finn and Jake have a related question. They want to know, do you have any hobbies?
Yeah, well, fishing. I like soccer. Um, and I really like to go to the sea. That is probably one of my biggest hobby. Be at the sea and look at you around. That picture is from Saipan, one of my last trips over there, and that was fantastic. The Saipan is in the Marianas Island. It's a tiny island, and that is a marine protected area. So that was fantastic. Being in the water as a hobby, that was really nice.
We've got a question from Cameron in North Carolina. Wants to know, where did you enjoy diving the most?
Definitely warm water. Whatever is warm water, I will do that. I was, as I mentioned before, I was in Oregon, and unfortunately, we have a lot of upwelling, which is basically the the movement of water from the deep, which is cold, coming to the surface due to wind effect. So what you have in there is basically almost year-round cold water. So for diving was not very good for me, but I have friends that they really enjoy it. So it's another view of what's in the ocean. You have different species of fish and different sizes and yeah, colors. And yeah, you should try to.
We've got just a few minutes left in the program, so we are going to go rapid fire into Q&A mode here. And actually, this next question, you just touched upon it. It's from Miss Border's class. They're in the Pacific Northwest. They're surrounded by water. They want to know how you'd compare the biodiversity of Hawaii with Puget Sound.
Oh, that's a pretty good question. I didn't get the opportunity to dive in Puget Sound, but I saw picture of people that were diving in there, and the biodiversity I think is it's you have more species in one place than the other, and but the number of individuals per species is different. So what is common between the two areas is that you have a lot of different shapes and different colors in this biodiversity of. I am talking here about fish, and especially and that was impressive to see, to compare. And actually, because I was working in that area with satellite data, and now I am doing the same here in Hawaii, so I can have an understanding of the dynamics that are producing this biodiversity in the two places.
Our next question is from David. He wants to know, what's it like living on a boat for extended periods of time?
I have, that's a good question, and I like that question because I have my own theory. I say that this is like a hill. Imagine a hill, a mountain. Basically, when you start in the cruise, you're very happy and you enjoy every single moment. But at some point during the cruise, um, you reach this point of that you start missing land and you start missing your family. But again, as time is moving in this direction, the curve goes down again, and then you are happy again, and you enjoy the last few minutes that you are going to be in that boat and doing what you want to do with your friends. At the same time, it's kind of nice to have your own room and have your own food. Somebody cook for you. You have your own bathroom. So yeah, the only part that I don't like much is when we have a rough sea and we get seasick. But yeah, besides that, it's fantastic.
We've got a very current event related question here. Did El Nino affect the Philippines super typhoon?
Oh, that's a good question. I am looking at that actually. I want to see how this change in surface temperature is affecting this pattern of these storms going. Sorry, going to Philippines. To tell you the truth, I can't answer that right now to you, but I hope to be able to do that very soon. As I mentioned before, we are working with institutions and universities in Philippines and Indonesia right now. So we are kind of concerned about this situation.
Our next question, another student in Mrs. Dabb's class wants to know, how are you not scared to be out in the ocean? And what does it feel like when you go and get samples?
I can tell you that that sensation of being in the middle of the ocean and just yourself, it's amazing. So I don't think so that I have been scared, except in one specific cruise in offshore Oregon, where the vessel was forced to, instead of go away from the storm, we were crossing the storm and going to the center, basically to reduce the amount of tilt and sickness in people. So yeah, beside that, for me, it's fantastic to be in the ocean. It's relaxing, and yeah, I really enjoy it.
Great. We've got time for one last question here. This is from Aiden. Wants to know, what is your favorite type of coral, and can you tell us about it?
Sure, I am not an expert in corals. I am just starting to learn about corals, but it is a table coral. I think Patrick has a short video that probably he can show.
Oh, you're going to put me on the spot.
Sorry to
Let's hope this
do
is
that
the
to
one.
you, but basically, yeah, that is table corals, and you can see that they look like tables, and you have a lot of biodiversity fish around these areas because you have areas where they can hide. They have a lot of food, and yeah, it's beautiful to be there. Very nice. I really like it.
So unfortunately, that is all the time we have for today's event. I want to thank Robert for joining us, and he's taking a lot of his time, not just during the live event, but leading up to it. And we really appreciate you telling us your story of your oceanography career. Really appreciate it.
Mahalo, Patrick. Thank you, everyone.
Great. If you are interested in continuing this conversation with Roberto, he has graciously agreed to stay connected. We're going to do that through Jason's Facebook page and through our Twitter account. So if you're interested in continuing to hear about Roberto's projects, or if you have more questions for him, shoot us up on Facebook, Jason Project Facebook page, and we'll connect you guys. So we really appreciate you being willing to do that as well, Roberto.
Thank you.
Awesome.
Hello.
Have a great day. But before we go here, I want to do a couple things. One, I want to thank Noah's Coral Reef Conservation Program's Reef Smart initiative. They helped to connect us up with Roberto, and we were able to chat with him today thanks to them. They're designed to increase awareness of NOAA's coral reef ecosystem research and conservation efforts. To learn more about them, go to coastalscience.noaa.gov/projects. I mentioned before that we've got some fossil-related stuff coming up. Actually, next week, we're back with a special program featuring the founders of PaleoQuest. Jason Osborne and Aaron Alford do scientific research by day, but on nights and weekends, they pursue their passion for exploration by researching and searching for prehistoric fossils. Much of their exploration is done in challenging underwater environments with almost no visibility, swift currents, and the occasional 9-foot-long alligator. When they're not diving for fossils, they support a program called Shark Finder, which allows citizen scientists just like you to search through material they've collected to discover and report ancient shark fossils. So learn much more about them during our live event with PaleoQuest next Thursday, November 21st at 1:30 p.m. Eastern. Hope you can join us. Once again, for Jason Learning, my name is Patrick Shea. Thanks for joining us today, and we'll see you next time on Jason Live. Take care.